Good morning. I'm Katherine Hambleton from NASA's Office of Communications. Welcome to today's pre-launch briefing for Orbital ATK's 9th contracted cargo resupply mission to the International Space Station. Orbital ATK's Cygnus spacecraft is loaded on top of the Antares rocket with cargo for the space station and its crew, including supplies for science experiments and technology demonstrations. Antares is scheduled to lift off during a window that opens at 4:39 tomorrow morning Eastern Time from the Mid-Atlantic Regional Spaceport Launch Pad 0A here at NASA's Wallops Flight Facility. Here to talk about how preparations for tomorrow's launch are progressing. Joining us on the phone, we have Kirk Shireman, International Space Station Program Manager from NASA's Johnson Space Center in Houston. Frank DeMauro, Vice President and General Manager of the Advanced Programs Division, Orbital ATK. Kurt Eberly, Vice President and Antares Program Manager, Orbital ATK. Doug Voss, Deputy Chief, Range and Mission Management Office, Wallops Flight Facility. And Kurt Costello, International Space Station Chief Scientist. After opening comments, we will take your questions. For those of you watching on TV or online, we'll take questions from social media using the hashtag AskNASA. And now I will hand it over to Kirk Shireman to kick us off.
Good morning. Thank you for being here this morning. We're very excited about having Cygnus fly up to the International Space Station. Over 3 tons of cargo will be traveling to the space station. Over 1 ton of it will be for utilization, research, and facilities. So we're really excited about having that up there. In addition, what's also important is it'll bring home almost 3 tons of cargo back away from the International Space Station. That's also a critical resource for us. Some of the highlights of the cargo that's going up is the Cold Atom Lab, a facility that will be the coldest place in the universe. We're really excited about having that on board, as well as some cargo to continue other research activities, including veggie plant habitat, e-field flames, and a host of others. In addition to Cygnus to launching tomorrow, a number of really big activities coming up for ISS, of which Cygnus will play a part. First off, we have crews coming home. We have Scott Tingle-Kanai, Noshigi Kanai, and Anton Skoplarov coming home on the 3rd of June. On the 6th of June, Alexander Gerst, Serena, Anton Chancellor, and Sergei Prokopiev will be launching the International Space Station. And that's important because we'll be doing the spacewalk on the 14th of June, which will be utilizing some of the cargo that's flying up on Cygnus tomorrow. So really important activities coming up. We continue to focus on the year in space and are making great progress and have a really, really busy year on board International Space Station. And we're very excited to have Cygnus going up and contributing to the activities this year. With that, I'll hand it back to you.
Thanks, and now we'll go to Frank.
Okay, thank you, Catherine. We're very happy to be back here at Wallops, ready for another launch of Cygnus to the International Space Station on our Antares rocket. We always excited to be able to bring vital crew supplies and scientific experiments to the space station. We certainly would like to thank the Antares team, our NASA customer, the NASA Wallops team, and certainly the Mid-Atlantic Regional Spaceport for all the hard work in preparing for this upcoming mission. We've got a video to discuss and show the processing of Cygnus and what we expect after launch, so we could cue that. So here's the service module arriving at Wallops. This is the cargo module, also arrives directly from our partner in Torino, Italy. Once that arrives at Wallops, we load it with about 75% of the eventual cargo that will fly. Once the cargo module is fully loaded, we'll mate it to the service module to create the Cygnus. Once Cygnus is fully mated and tested out, then we will move it to the V55 facility, fuel it for the mission, and then we install the NanoRacks CubeSat deployer, which is another mission where we'll be flying that important mission for NASA. After that point, we move it to the horizontal integration facility where it's mated to the Antares rocket, and then we can put the final cargo into the cargo module just before encapsulation, where the teams will install the fairing over the spacecraft, and that'll be the last time we'll see Cygnus until we approach the ISS. After liftoff, tomorrow morning. About 9 minutes or so after liftoff, Cygnus will separate from the rocket, and we'll begin the process of deploying our solar arrays, initializing our propulsion system, to begin the process of raising the orbit and starting the rendezvous with the space station. That process will take about 3 days, assuming we launch on tomorrow morning. So we'll get there about early Thursday morning. Cygnus will raise its orbit from the insertion orbit from Antares up to the space station orbit, about 400 kilometers in altitude. We will slowly make our approach from underneath the ISS, eventually getting to a point about 10 meters below the space station. That's where the crew will use the robotic arm to grapple Cygnus, and then they will maneuver the spacecraft and berth it to the Node 1 nadir port on the ISS. Once all the checks are completed, the crew will open the hatch and begin the process of unloading the cargo that we've delivered, and then over time installing the disposal cargo that we will take away with us after we leave the ISS. After we're unberthed, the arm will let us go, we'll back away, and then Cygnus will begin the process of moving away from the space station. On this mission, as in the past few missions, we will be raising our orbit above the ISS and then deploying 6 CubeSats from our external CubeSat deployer. And then once that's done, Cygnus will fly around, do a little bit more testing, and then we'll complete the mission with a destructive reentry over the South Pacific. Finally, I'd like to take this moment to express how proud we are to name this mission in honor of J.R. Thompson. J.R. was not only a veteran of NASA in Orbital ATK, but he was a great leader and mentor to so many of us. And we all had the pleasure of working with him for so long. He left an indelible mark on many projects at Orbital ATK, not the least of which is Antares and Cygnus. He was a mentor to all of us. He was a major part of what made Orbital ATK the company we are today, and we are honored to name the spacecraft the SS J.R. Thompson. So with that, go Antares, go Cygnus, and over to Kurt.
Okay, thank you, Frank. On behalf of the Antares team, I'd just like to say that we're very excited to be back here at Wallops with our NASA and Virginia space partners for the OA9 mission after a very successful OA8 mission that we conducted last November. And I see some familiar faces here, and I can guarantee that those of you who are here in person, you're going to be a lot warmer for this launch than you were for OA8. So I think that's good news. All right, I think I have a video to show too, and if we can roll that. All right, this talks a little bit more about what happens after Frank brings the spacecraft over. We unpack it from the shipping container, and we lift it out of its shipping container and onto the clamp band separation system that you see on the floor there. We rotate it to horizontal, and we load more cargo. And then here we see the Antares vehicle being lifted onto the tail. That's the transporter erector launcher that we use to transport the vehicle. And next, the fairing and Cygnus were lifted onto dollies in front of the stage 2. After final cargo load, Cygnus is mated to Antares, and the fairing is installed over top. We do a mission simulation test to verify communications, and then we move out of the HIF using our over-the-road transporters underneath the tail, and we go south on the island about 1 mile to pad 0A. After rolling up the ramp, the tail is connected to the hydraulic pistons that push the vehicle up to vertical. The tail continues to act as our umbilical mast through to liftoff. Fueling starts about an hour and a half before launch. The engines are ignited at L-0 to an intermediate power level. We do a quick health check, and then we throttle up the engines, and we all simultaneously release the vehicle from the pad. Antares flies straight up for about 25 seconds, after which it will pitch over and head downrange in a southeasterly direction. And a little over 9 minutes after liftoff, Cygnus will be separated into orbit. And from there, Cygnus takes over, as Frank mentioned, and performs the multi-day rendezvous to the ISS. Next, I'll talk about our launch preparation. Early this morning, we completed our major pre-launch verification test. We call that the Combined Systems Test, which verifies all the connectivity between the Antares rocket, the Cygnus spacecraft, the launch pad, and the range. That went smoothly, and we are now in final closeout activity in preparation for starting the countdown later tonight. The Antares and Cygnus teams will arrive on console at 10 o'clock p.m., and I hope they're asleep right now. The 6-hour, 15-minute countdown will begin at 10:24 p.m. The 5-minute launch window opens at 4:39 a.m. Eastern Daylight Time, and we will target the opening of that launch window. I'd also like to say a few words about J.R. Thompson. He oversaw the execution of our most important programs for over 20 years at Orbital ATK after a stellar career at NASA. And personally for me, he was a very strong mentor and leader whose determination and drive was an inspiration. I can honestly say we wouldn't be where we are today on this program if it had not been for JR's leadership. And we dedicate this launch to honor his legacy of achievement. And in honor of JR, our launch team will be wearing dark suits tonight on console with red ties, white shirts, and lapel pins, which really was JR's daily uniform. All right, finally, I'd like to say a word about public safety and airspace clearance. As you may recall, we had a small general aviation airplane enter the launch hazard area for our last launch that forced us to scrub for the day. I'd like to encourage everyone who is coming for the launch to please follow the directions of the Wallops Range, the FAA, the state police, and other public agencies who are working to ensure the safety of the public. We all want to see a good launch on the first attempt, so please do not try to go around roadblocks to gain a better view or fly an airplane into the hazard area to obtain the best launch video ever and post it on YouTube, or sail your sailboat into the hazard area. We appreciate everyone's cooperation, we really do, and we appreciate the extra work that the Wallops Range has done to raise public awareness, particularly within the general aviation community. Thank you, and we're looking forward to a good launch tomorrow morning. Doug?
Well, on behalf of the Goddard Space Flight Center, Wallops Flight Facility Range, and for NASA, I want to again welcome Orbital ATK and flying the Cygnus commercial resupply cargo. It's another opportunity to perform an important job for NASA and for the International Space Station, and Wallops is proud to be an important part of that, providing the range support. Just like the launch vehicle team mentioned by Kurt, the Wallops Range has been busy preparing for this launch for a number of months. And we've recently conducted testing with the launch vehicle team to assure that all Wallops range systems are operational and ready to support the launch. And that includes our Bermuda tracking and command facility, which we've been conducting testing with for the last 10 or 12 hours, and all systems are ready to go to support launch tomorrow morning. And speaking to the airspace violation from the last mission, Kurt is correct. Wallops has been preparing for this, and more importantly, working with the FAA and other organizations to make sure that we have every opportunity in place and every system in place to make sure that we mitigate the chance of that happening again. So Wallops has stepped up and is working that issue. There's a little bit of weather has been of concern lately. Anybody who's been around here for the last few days know that it's very wet. And so for the next couple of days for this launch, we're watching the weather very closely. Our Wallops range meteorologist this morning in the launch readiness review reported a probability of violation that was fairly low, but still something that we're watching and is, we'll keep a watch on. But everything is ready to go for the launch. And again, Wallops is very proud to have this opportunity again to us to support the commercial resupply. That's all.
Thank you, Doug. So, as you heard Mr. Sharman say at the beginning of the briefing, we're very excited to have the Orbital ATK Cygnus arrive. It's bringing with it over a metric ton of hardware and supplies dedicated towards the research on the space station. This is enabling 50 investigations and 2 new facilities to be delivered, among them the NASA Cold Atom Laboratory and ESA's Ice Cubes facility. This includes 34 new investigations that will be showing up for the first time on the space station. So why do we do research on the ISS? One of the prime reasons, of course, is the aspect of microgravity. In a microgravity environment, we enable new theories to be tested out. For instance, the Cold Atom Laboratory needs the microgravity environment to be able to reach that coldest man-made temperature anywhere in the universe. This enables them to use weaker and weaker magneto-optical traps to keep the atoms in place, which allows us in the end to get to lower temperatures because those atoms don't fall out of the traps due to interactions that would be driven by gravity. Another investigation going on is the continuous liquid-liquid separation investigation in micro-G. And here, Zyput Flow Technologies is testing out a novel separation technique for immiscible fluids that relies on surface tension. In microgravity, surface tension becomes the dominant force in liquid motion and dynamics. So it'll be interesting to see their results in a microgravity environment. We also have the microgravity investigation of cement solidification going on board. And this is a look at how we would mix and solidify cement in a microgravity environment, possibly for the construction of future space habitats. So in a microgravity environment, you don't have buoyancy-driven convection. Lighter things don't float to the surface, heavier things don't sink to the bottom. This eliminates some of the convective forces that are driven by heat. So it'll be interesting to see in these cement reactions how that impacts the overall solidification of the cement. We also have some life sciences going on board for the first time. We have Plant Habitat 01, which is an investigation by Dr. Norman Lewis out of Washington State University. This is our first use of the Plant Habitat Facility for science. And the Plant Habitat Facility brings on board a closed environment, unlike any other plant growth environment that we've had to date on station. This will really allow us to look at all the variable parameters in an investigation and get down to the brass tacks of what's going on in microgravity. Another reason that we like ISS for research is the fact that our commercial space transportation partners and our commercial providers for research facilities have made it much easier to get educational investigations on orbit. And we have a number of those going up on this flight, several of them from the Quest Institute and an investigation from higher orbits as well. We'll be looking forward to seeing those students complete their investigations on orbit. And last but not least, we like ISS for research because of the view. Not only the view, but the environment. It allows us easy access to that low Earth orbit environment, and it allows us to observe the Earth, in this case through a trio of CubeSats that are going to be deployed from the GEM airlock and the NanoRacks CubeSat deployer. Those are Cubert, Tempest-D, and RainCube, all of them testing new novel technologies to monitor our Earth's storm environment and our Earth's observation capabilities. And the last and final CubeSat I'll mention, since we've mentioned everything looking from atomic molecules to our Earth, I'll mention HaloSat over here on the left. HaloSat will be looking at X-ray emissions around galactic clusters and galaxies. So with that, we have a full complement of research on board, and we're looking very forward to the launch tomorrow.
Thank you. Now we will take questions from those joining us here today, as well as those on the phone. Those on the phone should press *1 to be entered into the queue. And please state your name and affiliation and to whom your question is directed. And a reminder for those watching from afar, you can ask questions online via the hashtag #AskNASA. We'll start right here in the middle. Please wait for the microphone to come to you.
Hi, Jared Hayworth from We Report Space. This is a question for Mr. Eberly. Can you talk to us a little bit about the technology that allows Antares to have a 5-minute launch window compared to the instantaneous window for Falcon 9 or the 30-minute window for Atlas V? Thank you.
Yeah, I think that's a good question. It really comes down to the fact that how much energy do you want to devote to steering, and how much do you want to devote to lifting more mass into orbit? That's a trade-off. So to get to ISS, we need to put Cygnus in a very precise orbit to be able to, so that they don't have to use too much energy to catch up to the station. That means the right ascension of ascending node of the trajectory or the orbit that we put it in. That's roughly where it crosses the equator relative to where the ISS is crossing the equator at the same inclined orbit. That's to say, we can, the further off of the optimal launch time we launch, the more energy we have to devote to canceling out that error. So we've chosen 5 minutes. Before we had 20 minutes, we could have 30 minutes. It's just a question of how much we want to devote to that versus lifting more cargo. At this point, we're pretty mature in the process. We could go down to instantaneous and gain a little bit more mass to orbit if we needed it. But right now, we feel like we've got the right trade between operational flexibility of having at least 5 minutes to move around in versus being able to give the Cygnus guys the performance and the mass to orbit that they want. Sure.
Thank you. We'll take one in the back there in the middle. In the, oh, okay.
Hello, my name is Melody Williams, also known as Scientist. I'm a science communicator, educator, as well as an industry scientist. I have a question in regards to all of the amazing experiments that you're sending up with Cygnus. What is the turnaround time that you would expect from the astronauts there to complete all of these particular experiments, and when would you expect to receive this important data?
Okay, I guess I'll take that one. So the investigations going up are scheduled to be performed during the upcoming increment. So as Mr. Sharman said, we're about to start a new expedition crew on the space station, and over the next 3 to 6 months, we'd expect most of this science to be completed. Now, as far as returning it to the ground and getting the analysis back from some of that, that depends, of course, on how many samples there are, when the next available SpaceX for returning those samples are, and also the time it takes to analyze science. Science can be a pretty long process. And depending on the amount of analysis that needs to go into it, we see people typically publish within 1 year to 3 years, maybe 5 years, for some very long-running experiments. You can keep abreast of all of this and also understand in more detail what is each of the science investigations that we have on board by going to www.nasa.gov/ISS-science. We have a link on that page for experiments, and there you can get details of each and every experiment, along with the publications when they come out, and you can see that. Thank you.
Take one right here. And then we'll come over here.
Hi, I'm Chelsea Goad with Space.com. I have a more general question about the forecast and the potential issues with weather for tomorrow. So is there a current probability for the chance that it will be delayed? And if it will be delayed again, what is the time frame for that? And also, will this affect visibility at all? If it is not delayed, will it still be a highly visible launch?
Sure, I'll take that one. So the planned probability of violation, or the expected probability of violation for the first launch attempt is approximately 35%. And that is largely due to clouds associated with the requirement to have visibility of the launch up to a certain altitude. So there are 2 follow-on days scheduled right now, specifically that we're tracking, and they have probability of violations. The second day is about 45%, and right now the third day is approximately 25% probability of violation. So we've had a lot of weather recently, and there's a front system moving through. So on the second day, if we don't launch on the first day, there'll be weather to watch and more forecasts to pay close attention to on that. In terms of visibility, certainly the weather is potentially going to affect visibility. So we're certainly going to launch once our criteria are all met. But the clouds are part of that formula. So sometimes the clouds enhance visibility because it lights the sky up a lot better. So sometimes that happens.
We'll now come over here to the front.
Hi, thank you. Good luck. Ken Kramer for Rocket STEM and Space Up Close. For Frank, I have a question. Can you review for us, please, where we are in the current CRS contract? I think you're almost at the end. How many more flights do we have? When will CRS-2 start? How many flights are there? And when will that start? And what are the changes in the Cygnus, some of the changes you'll be doing that you can tell us about to bring more cargo and enhance its capabilities? Thank you.
Sure, Ken. So for the first question, this will be our 9th mission on the CRS-1 contract. We have 11 total. So we expect to launch our 10th mission later this year, and then our 11th mission the early part of next year. And that will close out the CRS-1 contract. And then we expect the CRS-2 missions to kick off the second half of next year with our OA-12 mission. On CRS-2, we have a minimum of 6 missions on the contract. Those will carry us through the early 2020s. How many missions we eventually fly total will be, of course, up to NASA, but we expect to fly twice a year for the next few years at a minimum. So in terms of the changes, the Cygnus vehicle is mostly the same. We will be carrying a little bit more cargo on the CRS-2 missions than we are right now. We also have enhanced our science capability on the spacecraft for those missions. Right now we carry up to 4 powered mid-deck lockers on those missions will carry up to 6 powered and 10 total. So a lot more science focused. The other thing we've done in working with our Antares team is to be able to load cargo later in the flow than we actually do right now. In fact, starting on OA11 early next year, we'll be putting cargo as late as 24 hours before launch, as opposed to now where it's roughly 3 days. So we'll be loading cargo near the pad, and then just going right up to the pad and raising the vehicle to vertical. So we're looking forward to doing that on OA11, and in fact OA11 we're also slated to fly rodents for the first time. So some really good upgrades, but as part of our CRS2 approach, we've tried to minimize the investment required to get those capabilities in line, and we think we've been successful, so we're excited for that.
And do you have the total cargo under the CRS1 contract? Total cargo delivered?
Yeah, it'll be upwards of 30,000 kilograms total on CRS1.
Thank you. We'll go here. Let's see, it looks like 5th row maybe.
Hello, my name is Austin. I own and operate a YouTube channel called Euphoric Intentions. My question has to do with integrating NASA's space operational systems to be something more of a civilian interactive organization in the future. Obviously, these tests and experiments are gauging how these systems work and operate in space to fully and better understand them, so that hopefully one day space travel can be something which can be ingrained in the fiber of our society and civilization. Is this a NASA hopeful that one day, I guess, space exploration and travel can be something which is intertwined as day-to-day commutes in vehicles?
Let's see, this is Kirk Sharman. I'll take that one. So one of NASA's goals is to commercialize low Earth orbit. So there's already a large number of commercial activities going on. I think this flight is a perfect example. NASA buys a service from Orbital ATK. So NASA doesn't own the rocket. NASA actually doesn't operate the rocket or the spacecraft. All that's done by a commercial enterprise. Here it's Orbital ATK, and they do a fantastic job. So our NASA's goal in doing commercial cargo, we're doing commercial crew, a number of experiments and facilities are all financed, and customers are sought after by commercial companies. So again, I know this is a great flight too. There's CubeSats are being deployed on this flight after Cygnus leaves ISS. And those CubeSats are deployed by a company called Antares, who went out and found their customers themselves. So this commercialization is the plan, and by which NASA is hoping to hand over low Earth orbit to commercial enterprises. And the hope is that citizens such as yourself and anyone else could go conduct activities in space in the future however they would like. So that would open up certainly commerce activities, but it could open up tourism, could open up really anything. So we hope in the very near future that this will be some activity that anyone, not only in the United States, but really around the world, could participate in space. And what you're seeing happening here in front of you in the next 24 hours is a step in that direction.
Thank you. Next, we'll take a question from social media.
Okay, we have a question from Twitter. Mike asked, does the weather affect Antares tanking?
Frankly, the temperatures we use are so cold that we're really not affected by small variations in the ambient temperature. We have a lot of air conditioning that we blow into the payload fairing, into the intertank bay, and the aft bay. So there's really 3 volumes inside the rocket that we keep conditioned. So if it's cold outside, we blow warmer air. If it's hot outside, we blow cooler air. So we keep everything nice and conditioned on the inside, and then we load this cryogenic oxidizer, liquid oxygen, and it's at about minus 280 Fahrenheit. So small variations in the ambient temperature don't really affect us.
Thank you. We'll take the next question by phone.
Faust, your line is open.
Hi, good morning. Jeff Faust, Space News. Question for Frank or Kurt Eberly. Assuming that Northrop Grumman's acquisition of Orbital ATK does in fact close in the near future as expected, what changes, if any, to Antares or Cygnus operations do you expect besides the change in the corporate logo? Thanks.
From our perspective, we don't expect any changes to the operations. Both successful programs and very capable vehicles, and we expect to build and test and operate them the same way we've done it before. We have great teams working on both programs, and no, I don't expect any changes going forward.
Thank you. Do we have additional questions here in the room? We'll take one up here in the front.
Hi, congratulations on getting the Commercial Resupply 2 contract. Now there is a new competitor in the mix, Sierra Nevada Corporation. How does Orbital ATK plan to deal with that additional new competition?
We'll deal with it by continuing to do what we're doing. We have as I mentioned the last question, we have a very capable spacecraft and launch vehicle, and that's part of the CRS-2 contract. We've improved our capability. I think from our point of view, certainly I won't talk about the competition, but from our point of view, we've provided NASA on CRS-2 what they were looking for, which is more cargo for lower dollar per kilogram pricing and more science capability. And so we've provided that. And by staying with our products with relatively minor upgrades, we've been able to keep the additional NASA investment in development down significantly. So we'll continue to provide what we think is an extremely valuable service to NASA, both providing pressurized up mass as well as, as Kirk mentioned, the critical service of pressurized down mass. We have other capabilities we've offered in that. So far, NASA hasn't taken advantage of those, including unpressurized up mass. But no, we'll keep doing what we're doing. We'll increase our capability as we go and make sure we're responsive to our customer.
Thank you. We've got another question from social media.
Yes, Jamie on Twitter asks, if for some reason the weather becomes really bad and threatens the well-being of the Antares rocket, would it be moved from the launch pad and stored in a safe place?
Yes. No, we have a number of contingency plans, and we've actually been out on the pad with the first stage that we were planning to do a stage test with, and a hurricane came along. So we certainly have plans to take the vehicle down, put it back on the transport vector launcher, and get it back inside our horizontal integration facility, which we can do in roughly a long day. So we have those plans in place. We're fairly impervious to rain. It's been raining off and on the last several days, so we've got things buttoned up, and like I said, we're blowing a lot of conditioned air on the inside and keeping the water out. When we're attached to the launch pad, we're firmly clamped down at the base, and we have a gripper arm around the front, and so winds are also not a concern up to really kind of hurricane level winds. So we hope that the range will provide a little heads up on a hurricane coming our way, and then we will quickly exit back to the HIF where we would ride that out.
Thank you. Are there any other questions here in the room?
One more.
Okay.
I've heard rumors, Arsenio from Twitter. I've heard rumors of aims for space, human raiding the spaceport. Do you have any answers to those rumors?
I'm sorry, could you repeat that? Aims?
I've heard that there are aims to human raid this spaceport.
The spaceport itself? Doug, are you able to speak to that?
Yeah, I'm not really able to speak to that. The rumors, as far as I know.
Thank you.
Thank you.
Any other questions here in the room? One more, and then I think we'll wrap up.
Jana Slesarchuk, 1+1 TV channel Ukraine. I have a question about cooperation with Ukraine on the first stage. Could you comment on that, and could you comment on the cooperation with Ukraine on the when the rocket will launch?
Absolutely. Yeah, we purchased the first stage core from two companies in Ukraine, Yuzhnoye and Yuzhmash. Yuzhnoye is the design bureau, and Yuzhmash is their sister manufacturing center. and they are excellent suppliers. They are the designer and the manufacturer of the Zenit rocket, which has flown successfully for many years, notably on sea launch, if you remember that program, and land launch. So we are happy that they're a supplier. They're a very good supplier, excellent engineers. We have some of their engineers and technicians come here to Wallops to help us integrate, and we do have a room where they are going to be looking at telemetry during the countdown, and we appreciate their support, much the same as any other supplier, and they're excellent aerospace engineers.
Thank you, and I think we have one more question here in the front.
Hi, Ken Kramer again. For Kirk Shireman, NASA's contracts with Russia, actually, for Soyuz flights are running out soon. So what is NASA doing to, and you may have to reduce the staff, what is NASA doing to come up with seats for astronauts if the commercial crew flights don't come on late this year, early next year? Thanks.
So this is Kirk Shireman. Yeah, that's an interesting question. Of course, as you might expect, we've been thinking a lot about it. We're in an unusual position in the sense that, NASA's focus, the focus of the United States, is to get the commercial crew providers flying and flying safely. So that's our number one focus. We do have Soyuz seats through contracts through the end of the calendar year next year, and really on into the first month or so of 2020. So the first thing we did is we worked with our Russian colleagues to go extend to the maximum extent possible those flights next year. That's the first thing. And then we're looking at other options of how we might do it. The issue is we don't want to go pull the trigger on those other options before we know that the U.S. providers won't be ready. So part of it is just asking, working with our Russian colleagues about what options are available and when we would have to make decisions. And so far, flying.
Thank you. And with that, I'd like to thank everyone for joining us. You can find out more about the mission and the science and technology on board by visiting nasa.gov/orbitalatk, as well as nasa.gov/station. Thank you for joining us.